Thanks. So this is joint work by me, Michele, and David. So I will be giving the first half of the talk, and he'll give the better half, the second half. And all right, so an empirical argument for presentism. This is familiar debate in the metaphysics of time, presentism versus eternalism. I think we know about it, but presentism is the view that only present things exist. So I do, and you do, and this table does exist, but Socrates doesn't, nor do Martian outposts. Eternalism, in contrast, is the view that past and present and future things all exist. Not only us, but also Socrates and Martian outposts. It's a metaphysical debate, and there is arguments for and against those views. And interestingly, there's an empirical argument that has been given against presentism and in favor of eternalism. The argument from relativity. The rough idea is that presentism needs an absolute time, which seems to be in tension with relativistic physics. So the consensus seems to be that empirical considerations favor eternalism over presentism. And we want to undermine this consensus. And our goal is to give an empirical argument in favor of presentism by pointing to an overlooked feature of our laws of nature in this universe. And by arguing that presentism can explain this feature of our laws of nature while eternalism can't. So the roadmap for our talk is that first, we will present this feature of our laws of nature, Markovianism. And we are going to argue that our world is Markovian. And we're going to argue that eternalism cannot explain this feature of our laws of nature. Then we're going to argue that presentism can, at least some version of presentism can explain and indeed entail Markovianism. And we're going to conclude with a discussion of the relative merits of these empirical considerations for and against presentism. So Markovianism, or Markovian laws, is a technical term, and the intuitive idea is that some laws are Markovian if the past does not place any causal constraints on the future that go beyond the present. One can imagine, in other words, that in a Markovian sequence, the state of the system at a time is sufficient to determine the future states without needing to look at the past. Just to illustrate it, let's look at the toy binary Markovian universe. So 1, 0, 1, 0, 1, 0 forever. This is Markovian because if I tell you that we are in a state labeled 0, then we can know what are the future states. Future state is going to be a 1. If I tell you we are in a state labeled 1, then the future state is going to be a 0. In contrast, if you consider the toy non-Markovian universe, which is 0, 0, 1, 1, 0, 0, 1, and so on, the same thing does not hold. If I tell you that we are in a state of 0, that's not enough to determine the next state, because it could be a 0 if the previous state was a 1, or it could be a 1 if the previous state was a 0. So that is the contrast of Markovian versus non-Markovian sequences. So we can formulate then, in terms of physics, going beyond toy models, in terms of the actual world, the claim of Markovian determinism. And it is the idea that for any time t, if we let ht be the intrinsic state of the history of the universe, up to and including time t, we let capital T be the intrinsic state of the universe just at time t, and then we let t plus be the intrinsic state of the universe strictly after t, then Markovian determinism is the claim that for every time t, if it is nomonologically necessary that t plus instantiates some intrinsic property or other, given ht, namely given the whole history up to time t, then it is nomonologically necessary that it instantiate that property also given only t, namely only given the present slice. You might worry that this definition builds in determinism, but it can be easily adapted to chance, just by saying that the chance facts about future events condition on the whole history of the universe up to time t, are the same as the chance facts conditional just on the slice at time t. Now there's a question. Is our world Markovian or not? And we think it's an empirical question, right? So it's on science and get out of here. And the answer is, we think the answer is yes. Our world is Markovian. Namely, our best physical theories entail that the laws of physics are Markovian. Let me just illustrate it in a couple of ways. For classical mechanics, yes, it's false, but still. If we know the positions of all the particles now, and their masses, and also their velocities at the time, that is enough to determine the entirety of the future history. We don't need to look at the past or where the particles were yesterday. Or in quantum mechanics, the wave function of the universe at the time is enough to determine the chances of the wave function evolution in the future. There are two qualifications that we made to this claim that our world is Markovian. One might worry that the definition is just incompatible with relativity theory because we quantify over times, and in relativity theory there might be no absolute times. But we can reformulate the claim as saying that Markovianism is understood as holding either in all inertial reference frames, which would be true for special relativity, or in all global foliations of space-time, or general relativity. Second qualification is that I said, using classical mechanics as an example, that if you give us the present positions and velocities of all the particles, then we have Markovianism. But you might worry that velocities are extrinsic properties, if you believe in the ADAT theory of velocity. So you might worry that Markovianism would be false if you think that velocities are extrinsic properties. First thing to say is that this problem does not arise in quantum mechanics, and of course, the overwhelming empirical evidence that quantum mechanics, better than classical mechanics, is true physics. Secondly, even if velocities are extrinsic, the fact that our laws are compatible with Markovian, subject to the answer to some debate on the metaphysics of vector quantities, is an interesting enough claim. And so our world is, say, Markovian, and then, well, our question is simply, why is that? It's a pretty surprising fact. We wouldn't expect a priori for the laws of nature to be Markovian. And we're gonna try to argue that eternalism cannot explain it at all, but presentism can. Let's begin with eternalist approaches to Markovianism. And we think that there are roughly two strategies that eternalists can have to explain Markovianism. It corresponds to the two conceptions of the laws of nature that they might have. And the first conception is the human conception, and there's a non-human conception. The human conception of the laws of nature is one in which the world is a vast mosaic of local intrinsic qualities. There is no necessary connections between disjoint regions of space-time. Laws are just summaries of regularities that we find in this mosaic, subject to some constraints. So they have to be simple, informative summaries. And we think that this view cannot explain Markovianism, just because if we look back at the toy world, 0, 0, 1, 1, 0, 0, and so on forever, which is a non-Markovian world, this world is perfectly compatible with humanism, and there seems to be no reason why a human approach would rule this out. And this is connected, we think, to the old point that humans in general cannot quite explain regularities. And then there is non-human approaches, and I will leave it to David.
Should a light be on? Can you hear me? Okay, I think I'll just sit down. Okay, so we looked at one kind of strategy that the Humean might pursue, or that the Eternalists might pursue via Humeanism, and we think Humean Eternalists just a root inexplicable coincidence that the laws are Markovian. And now the question is, can the non-Humean Eternalists do any better? So there's various different kinds of non-Humean Eternalism, but start with the generic point, and then we'll go to the specifics. So generally, non-Humeanism is the view that there's some kind of metaphysical posit, and people differ about what it is, that secures necessary connections in nature. And they do this to try to provide a robust explanation for the regularity of the world. The first point to make about non-Humean internalism is that just at this level of generality, it doesn't give an explanation for Markovianism. So let's grant the non-Humean that they can explain why the world is regular or simple or something like that. That's still far from explaining why the universe is Markovian. There are plenty of very regular and uniform non-Markovian worlds. Again, take our toy case, 11001100. That's an extremely regular, uniform world, but it's non-Markovian. So merely explaining why the world is uniform or regular doesn't suffice to explain why the world is Markovian. So at this level of generality, the non-Humean internalist still just a coincidence. So let's look at more specific versions of non-Humeanism. So the first kind of strategy appeals to universal. This is defended by people like Thule and Armstrong and Gretzky. So on this kind of view, there's a necessitation relation between universals, which we can call NFG, which is supposed to necessitate that something like all F's are G's is true. The reason why all F's are G's is because there's a necessitation relation between the universal Fness and the universal genus. We think that there's nothing in this account that will permit you to derive Markovianism, which is a very precise claim about how the laws of nature relate to time, but we don't see a way to get from merely the claim that all F's are G's to Markovianism. More specifically, there's no special role that time is given in this account. There's just these necessitation relations between universals, and Markovianism is a very mathematically precise principle relating laws to time. So it's very unclear to us how one could derive Markovianism from this kind of account. This dovetails with a much more general objection that's been given to this approach in the literature, that it's unclear how this kind of approach is supposed to deal with actually scientifically relevant laws of physics, which are sort of differential equations, rather than all F's are G's. And if they have trouble dealing with realistic laws of physics in the first place, it seems like they're going to have trouble dealing with this very specific claim about the laws of physics. Okay, so other non-Humean internalists appeal to primitive laws. They say the reason why there are natural regularities is because there's just a primitive law that such and such regularity obtains. And this proposal, we think that's sort of the opposite problem as the other proposal. So the other proposal, the universals account, was committed to saying that laws must be uniform, all F's are G's. And that seems kind of restrictive, and it's unclear how to get real laws from that. But this kind of proposal doesn't put any restrictions on what laws are. Laws are just entirely primitive things. They can attach to anything, it seems. And so if laws are entirely primitive, it seems that anything can be a law of nature. So there's no explanation why it couldn't be a primitive law that some non-Markovian regularity could be true. So for example, with the alternating 1100, 1100 world, why couldn't that be a primitive law? So we think primitivism doesn't have the resources to try to derive Markovianism because it's too primitive in a sense. There's one last kind of non-Humean eternalism, which we think is the best way forward, but we think it doesn't work. But here's our sort of suggestion on behalf of this kind of approach. So this approach is based on causal powers. So it says the reason why there are natural regularities is because fundamental properties like mass or charge or spin or whatever have a certain kind of causal power. And here's our suggestion on behalf of those kinds of theories for how they might try to explain Markovianism. They might say something like this. Look, perhaps causal powers have to act in spatiotemporally local ways. And one can think of violations of Markovianism as sort of like violations of locality, particular violations of temporal locality. If you think of it, violations of locality or violations of Markovianism are instances where the past sort of influences the future by sort of skipping the present. And so you can think of that as a kind of violation of temporal locality. So perhaps if the causal powers eternalists could appeal to this feature, they could explain why Markovianism holds. We think this is by far the most promising proposal, but we think it has two really big problems. The first problem is that it's not sufficiently empirically robust. So there are various physical theories, both historically and in contemporary times, that violate locality. So historically, Newtonian gravity violated locality, sort of gravitational interactions were instantaneous between massive bodies, and there was no sort of communication between the two massive bodies. But also in contemporary times, various interpretations of quantum mechanics violate spatiotemporal locality. Various kinds of collapse approaches to quantum mechanics, as well as Bohmian mechanics, all violate spatiotemporal locality. But importantly, none of them violate Markovianism. So Newton's laws didn't violate Markovianism. Bohmian mechanics doesn't violate Markovianism. Collapse approaches don't. So we think there are lots of viable physical theories that do violate locality, but none of them violate Markovianism. So we think explaining Markovianism via spatiotemporal locality is, in a sense, not empirically robust. But we think there's a stronger separate problem that faces this approach. And basically, we think there's a dilemma. Either you think that it's necessary that causal powers act in local ways, or you don't. You think it's merely contingent. And we think there's problems either way. So if you think it's absolutely metaphysically necessary, we think this needs further argument, because there are scientifically realistic possibilities where locality is violated, like Bohmian mechanics. And if you think there's a connection between conceivability and possibility, it seems like you can easily conceive of non-Markovian worlds, like the 1100 world, for example. So it seems like because of these conceivable and scientifically realistic possibilities, I think if you think it's necessary, then I think you need to do more explaining. But if you think it's contingent, then the problem re-arises of why does it happen to be that the actual causal powers happen to act in exclusively local ways? Is that just an inexplicable coincidence, or is there some kind of deeper explanation? So we think ultimately the proposal doesn't work on its own terms, and furthermore, it's not really empirically robust. Okay, so that is why we think that eternalism doesn't work. So whether you're a Humean or a non-Humean, what different version of non-Humeanism you have, we think all of them render Markovianism just a completely brute, inexplicable coincidence. And we don't want it to be a completely brute and inexplicable coincidence. We want some kind of explanation as to why it holds. And luckily, we think that the Presentists can offer such an explanation, even though the Eternalists cannot. So let us turn to present. Okay, so the motivating idea behind the thought is very simple and very flash-footed. The reason why the past can't influence the future in ways that goes beyond the present is because there is no past. The past doesn't exist, so obviously it can't influence the future in ways that bypass the present. So that's the obvious flat-footed reply. And we think it's ultimately right, but it has to be finessed. So here's a problem for the sort of flat-footed reply. There are certain versions of presentism that can be made to violate Markovianism. So here's an example. Suppose you think there are primitive 10th truths about what was the case and what will be the case. And suppose you think there are primitive laws of nature that latch on to these primitive 10th truths. So suppose you think it's a primitive law that if it was the case that P, then it will be the case that Q, where that law bypasses the present. We think this is an example that shows that presentism on its own doesn't give you Markovianism. You need some extra assumptions. And so for the rest of the section, we're going to hash out those extra assumptions. We're going to give, in particular, two specific versions of presentism that we think entail Markovianism. So the first one will be a generic version of presentism combined with a particular non-Humean view. And the second one will be a generic version of non-Humeanism combined with a particular presentist view. So let us start with the first proposal. So the first proposal is to combine presentism with the view that there are no primitive laws or interpretation relations. The only way that there are causal constraints in the future is via the causal powers of fundamental physical entities. So we reject the primitivist view, reject the universalist view. We think the only nomic connections are grounded in powers of things. And on this view, we think there's a case to be made that Markovianism follows just by two very simple points. By presentism, there are no past objects, and so hence no past objects with causal powers. And by the causal powers view, the only nomic constraints on the future come from causal powers. They don't come from primitive laws or anything else. And so we think that combining the view that presentism is true, together with the view that causal constraints must be grounded in concrete reality, we think you get Markovianism. This is a kind of Aristotelian view where sort of nomological necessary connections have to be grounded in being and can't be sort of offloaded into primitive sense groups. So that's the first kind of proposal that we think gets you Markovianism. Here is the second proposal. So the second proposal involves a particular version of presentism and a generic version of non-Humeanism. So you can have any non-Humean view you want, you can have primitive laws or whatever. But here's the version of presentism at issue. It's motivated by the standard truth-making objection to presentism. So it's a very standard objection that how could there be truths about the past and the future if there is no past and future? What would make those truths true? And there's a bunch of different views on this question. Here's one sort of natural view one might have that's been defended by Ned Markovian recently, but lots of other people in the past. Let's call it Nomic Presentism. That's the view that insofar as there are tense facts about the past and future, they're true because they're guaranteed to be true based on the present state of the universe and the laws of nature. So if the moon will exist in 2 minutes, the reason why that's the case is because the laws in the present state require that the moon be there in 2 minutes. And if the laws don't require that, then it's just sort of indeterminate of whether the moon will be there. We think that combining this view, Nomic Presentism, with any version of non-Humeanism you like, primitive laws, universals, whatever, will get you Markovianism. Why is that? We think it follows just from sort of logical reasoning about the structure of valid arguments. So the point is that on this kind of view, the past and present can't necessitate any future truths that aren't already necessitated by the present. Why? Because all the past truths themselves are already necessitated by the present. So here's a sort of very abstract point on the slides for any propositions P, Q, and R. If P and Q together necessitate R, where here we think of P and Q as truths about the past and the present. And if P already necessitates Q, so if the present necessitates the past, and that's the case on Nomic Presentism, any truth about the past has to be necessitated by the present in the laws, then P necessitates R by itself. So basically, because the only past truths there are ones that are necessitated by the present, adding the past truths can't get you beyond what the present says. So we think this is a totally alternative case where presentism implies Markovianism combined with any version of non-Humeanism you like. Okay, so that is basically why we think that certain versions of presentism can handle Markovianism and Eternalists can't. And so summing up, we've argued that the facts that the laws of physics are Markovian is just a completely inexplicable coincidence given Eternalism, which is happy fact. But that's not the case on presentism. On presentism, you have to be Markovian. In fact, you can sort of do the contraposition here. So if physicists announce tomorrow, we've discovered the laws of physics are non-Markovian, we think we should just give up presentism. Presentism would have been refuted because there's only present things. And so if the laws of physics require the past, then we think, at least I think me and Michele would just give up presentism if physicists announce tomorrow that there's non-Markovian laws. And so we think presentists stick their neck out and make an empirical prediction. And that empirical prediction has been spectacularly confirmed by all of physics, from Newtonian physics all the way to quantum field theory. And we think that's a very strong point in favor of presentism. So one last slide. So we haven't talked at all about relativity. We've just given a totally different argument that has nothing to do with relativity. But we want to talk a bit about the comparison. So there's a natural question, what are we supposed to do in this kind of case? There's two separate arguments on opposite sides. Relativity seems to say that we should be eternalists. Markovianism seems to say that we should be presentists. Which should we think is stronger? We're inclined to think that the argument for Markovianism is stronger than the argument for relativity. So why do we think that? Well, the first reason we think is that the fact that the laws of physics are Markovian is just more empirically robust than the fact that the laws of physics don't require absolute simultaneity. think it's a live issue in foundations of quantum mechanics, whether certain interpretations require simultaneity. Bohmian mechanics seems to require it, certain collapse interpretations require it. So we think it's, a live issue. But basically every standard physical theory that's ever been formulated, from Newton's day to quantum field theory, seems to require Markovianism. So we think that it's just a much more empirically robust feature to central empirical arguments around. And second, it seems to us that the sort of standard replies to the relativity objection are more plausible than the view that Markovianism is just an inexplicable coincidence. So sort of the standard reply to the relativity objection is that, look, our best physical theories are compatible with there being an absolute relation of simultaneity. We can sort of supplement the physics with the privileged relation of simultaneity. It's just that they don't require it. There's things to say here about certain topological models of general relativity, but we can talk about a bit more about that in the Q&A if you want. But that's sort of the standard line. It's not required, but it's compatible, and we can just supplement it if we want. And we think there's lots of precedent for this. So there are plenty of metaphysical posits that seem to be justified without being required by physics. So you might believe in abstract objects, even though they're not required by physics. You might believe in reologically complex objects, even though they're not required by physics. You might think truths about consciousness are not required by physics, but all of us believe in truths about consciousness. So as long as you have independent reason to posit something, seems like it's fine to posit it. And we think there is independent reason to posit it because of Markovianism. And we think that reply is just better than the reply that Markovianism is an inexplicable brute coincidence. And so we think, the argument from relativity uses an empirical premise that's more dubious. And B, we think the standard replies to the relativity objection are better than just saying that Markovianism is a coincidence. And so we think the way forward for eternalism is to provide an alternative explanation for why it should be true. And we haven't come up with one, but we'd love it if other people can do that.
So thanks, this was very interesting. So I have just like actually a question of well, not clarification, but of curiosity. So do you think that your argument strictly applied just to presentism or to any theories? Because, I mean, do you appeal to some specific fact about existence, or it's just like, okay, you get the gist?
I can start. Right, you're thinking maybe of the growing block or something like that. Well, we think that...
Any privilege present.
Yes, well, we think that as long as there are all these other objects in the past and in the future, then there's a question, why aren't they interacting with the present objects, right? So we think that if you like growing block theories, for example, we see there's still a question of why do we have Markovianism? Some version, we think, of those theories, maybe those in which the objects that are in privilege don't have any efficacy in the world. Maybe we think that some views could explain it, or I think they're more niche, so to speak.
Yeah, I think I agree with that. So I think it will depend on the version of the A theory that's not presentist, but insofar as they agree that there are past objects, there's just a line of question. It's sort of up to them to see how to do it. But yeah, I think it'll be interesting. But I think the arguments we gave don't directly apply, so it would have to be.
Okay, so facts about existence are relevant for your explanatory. Yeah. Thanks.
So I'm a little confused about your treatment about Markovian laws in physics and your treatment about local laws in physics. Your argument is you start from the fact that current laws of physics are Markovian, although there are certainly non-Markovian models in physics. They may or may not be correct, but people in condensed matter use non-Markovian models all the time. But you use that as your basis. On the other hand, when you talk about locality, you say what's important is not whether current physics requires locality, which or somehow requires non-locality, but just that it's conceivable that one could have physical laws that are non-local. Isn't it equally conceivable that one could have physical laws that are non-Markovian? Why do you prefer one over the other?
Great. So yeah, there were two questions there. So the first one was, what about non-Markovian models in physics? We agree that if you go to like higher, like macro level physics, so like physical mechanics might appeal to the past hypothesis, and that's not discoverable just from the macro state. And that would be a kind of maybe a thing that violates Markovianism and perhaps condensed matter. I'm not sure the exact model we were talking about, but I guess it's we want to focus on sort of fundamental microphysics and whether Markovianism holds there. I think there might be very speculative like interpretations like retro-causal interpretations of quantum mechanics or proposals of quantum gravity, but we think it's a pretty standard constraint on sort of standard theories of fundamental microphysics when trying to quantum field theory. But they have this Markovianism, but we can talk about particular proposals if you want later. But the second point was we're not committed to saying that Markovianism is necessary or contingent. So with respect to the causal powers are conceivable, isn't it conceivable that locality fly with? That was in the context of a particular dialectical point. We were saying, can the causal power eternalist explain it? And we were giving a particular objection to this dilemma. Either you think it's necessary that causal powers act in local ways or not. We think if it's necessary, then in general, if you say something's metaphysically necessary, you have to sort of explain away the appearance that it's possibly false. And we think that there are such appearances because there are scientifically realistic cases that violate locality and conceivable situations. But we're not, with respect to Markovianism, we just need the empirical fact that Markovianism is true. And we think that empirical fact is evidence for presentism. We're perfectly fine with it being an empirical fact that non-Markovianism is true. And then we give up presentism. We say presentism is falsified, turns out non-Markovianism is true. So we're not committed to the question of Markovianism. And the thing about the causal powers thing was just in the context of a particular dialectical point.
Can you hear me?
Yeah.
Yeah, I had a follow-up. That's why I skipped the line. Sorry, I'll be super quick. On the first part, so I see why you're saying that there are parts of physics that might be non-Markovian, but you're not really interested in that. But again, the connection with locality for me, it's strong there because like the parts of the physics that are non-Markovian, for instance, the open systems, these are non-Markovian, or at least the supposition, I guess, they're non-Markovian because the interaction in the bath, in the environment, let's say, it's very strong due to entanglement, which relates the dynamic at different times. So the reason why part of the physics, quantum physics, is non-Markovian, and a large part of quantum physics is non-Markovian, is because of entanglement, which then you interpret however you want. But again, I was super interested in the idea of moving from Markovian processes, like physicists say, to Markovian words. This is super cool. But again, I still don't very much. I don't see the argument that our word is Markovian. I mean, it needs more, as far as I understand, more arguments. Thank you.
So I think so. If you just look at like the Schrödinger equation that governs quantum mechanics and quantum field theory, it's just you take the wave function at a time, and then you get the Hamiltonian and you evolve it, and that's perfectly Markovian thing. You just need the wave function at a time. So there's a question whether these views violate Schrödinger's equation or whether they're recoverable from Schrödinger's equation. So I think if you believe in Schrödinger's equation, then I think you're committed to Markovianism. But perhaps I think we just have to look at the details of what you have and whether it's reducible or violates it. But yeah. We need to write it down. We can go. Yeah. I'd love to talk about it.
I mean, it's how much you want to do. Like, I think,
so maybe certain predictions of quantum mechanics will supplement the Schrödinger equation.
No, I'm just saying that what you were saying about the concept, that's right. It depends on how you interpret the concept. And I don't know, it might be like sound as with the time, sound as with the time. It's like there are things that are even though the way I think there's a lot.
Yeah, so I think, I mean, if you look at the Copenhagen interpretation, the probabilities of the collapse are determined by the present wave function. You look at the amplitudes and the places and everything. So if there are like a proposal for how collapse happens that's explicitly non-Markovian, I think that'd be interesting. But yeah, it's the places. Okay, so yeah, so I think those would be intentional.
Me? Yeah, I suppose a lot of people would respond to you by just saying, well, maybe nature is kind, and that nature is kind, and it's Markovian. But I actually agree with you that it's that all this kind of Markovianness all over these kind of fundamental or non-fundamental laws is kind of suspicious. But that's the last place I agree with you. Everywhere else I disagree. So, on the Humean theories of laws, I think most Humeans now have this kind of strong pragmatic element where they think of the Humean laws as these kind of, partially prepared solutions to frequently encountered problems, by human beings. And then you have this kind of beautiful explanation, I think, of why things are Markovian, because the answer is kind of staring you back. You're looking in the mirror, and it's you. And because human beings, it's a lot better to use those sorts of theories. If I crucially required information from 1837 to solve some sort of billiard ball problem now, that would be not very useful. And then on the non-Humean side, the laws are primitive, and so I've seen the exact opposite claim where people say, well, it's nice to have these primitive things because we just throw them around anywhere, and so if the laws turn out to be these, this kind of atemporal, like some kind of extremal principle thing, or retro-causal quantum mechanics or something, it's nice we can just slap on this non-Humean constraint. And then on the last part, that's where I really mostly disagree. I mean, I don't see what's empirical. I mean, so Schrodinger, so imagine it's like May, June 1926, Schrodinger sitting there. He was thinking, oh, I'm going to write down a non-Markovian theory. And then he goes, oh, shit, the past doesn't exist. And he writes down the Schrodinger equation. So how would that, how does the past not existing end up influencing, is the data lost or something?
Yeah, right. Thank you. So it's a lot of stuff. First, you talk about humanism, and I mean, sounded you want to say something like, we as people, we as humans, if we're humans, we're gonna do our best to always find a Markovian interpretation of the facts. I would just say that sometimes this seems undoable. So if you consider the 0, 0, 1, 1, 0, 0 world, there's just no way to have a Markovian interpretation of that, because I know that we are at a point where it's 0. There is no way to see what the next point is without looking at the past. So I think that I wouldn't see how you could get that. And when it comes to the non-Humean point, I didn't quite get it, sorry. So maybe he's gonna have that. When it comes to the final part, what is the empirical aspect? Well, we think that we come here with an open mind, and we think that, again, it wasn't a priori clear at all that the laws would be like that. And if the laws were different, then we would think, well, with all this reason to accept this past object. Maybe that's what we do to see the flip side. If somehow we have this evidence that somehow, say, a particle existing long ago was exerting a pull on present particles beyond all the particles that there are now, and we could measure that force, that's an empirical fact. If that were the case, then we would take it as extremely strong evidence that the past exists. The fact that Schrodinger didn't have to look at the past to write an equation that explains everything, I think is empirical evidence that there is no such past thing that is needed. That's the way in which we think it is empirical. Because we don't know anything about the world, so we think, what are the laws going to be like? We think, who knows? There is a toy 0, 1 world, there's a 0, 0, 1, 1 world. Then we find out that we are in the first kind of case.
Yeah, I just want to add this. I mean, following up the last discussion we had, we've heard all these proposals. Maybe the collapse is not Markovian, almost condensed matter. So I think it's definitely a live empirical question. We can talk about specific proposals like non-Markovian collapse. I think it's definitely not a priori of Markovian. We can look at these particular models, and we think it's a very surprising fact that Markovian. And we don't think it's I mean, we'd like to have to be an applicable equivalent, but we think it is to eternalism, and that's why we don't like eternalism. And I think I agree with Markovianism. Yeah, the second point, I mean, I think you were saying stuff about how you don't like primitive non-Humean laws, and I think we both agree on that. We don't like primitivism, and that's why I think primitivism doesn't get you what you want. So I think primitivism with presentism, basically anything goes. We can look at these temperatures or whatever. But I think you're right that you need I mean, I think one part of your question was past doesn't exist, therefore our view is right. I mean, I think you have to look at the details. So we looked at two very specific detailed proposals about nomic presentism, and we looked at the logical validity and how that derives it, and then we looked at the Aristotelian formal power view. So I think the slogan, the path doesn't exist, therefore it can't influence, is good. But I think there is detailed stuff that needs to be done, and we'll have to look at the two detailed models for that. So yeah, we think it is an empirical question, and we can get it, and it's still inexplicable coincidence.
Yeah, I just wanted to follow up on your comment about the past hypothesis. So I'm wondering why you're so dismissive of it. Like, so the Humeans who defend that think it literally is a law, and it's one that essentially involves the beginning of the universe, and you need it for all of these probabilistic laws, right? And so I'm wondering, do you think, is that because you have some, like you said, you prefer the fundamentalists, the fundamental physics ones, or the microphysics? And I was just wondering how that would respond to the kind of Humean approach that says we don't have access to that kind of information. So if you're going to do this empirical thing and say we're just looking at what we're able to, you know, discover, I'm just wondering how these would play nicely with each other.
But yeah, I think that's a really good question. So yeah, I guess our starting data point is that when you look at the fundamental microphysics, it doesn't seem true. And I think all parties should agree to that, and the question is what explains that. And I think the path hypothesis is sort of downstream because it doesn't contest that initial data point that the microphysics is Markovian. And so there's still, that initial data point still needs to either be a coincidence or explained, and we have to. There's a separate question of like, downstream, is this a problem? And yeah, the initial point is, oh, the path hypothesis is baked into the microphysics, and so we don't need to have it. But there's an interesting like epistemic point of like, we don't know the microphysics, and so we need the path hypothesis. I would think that the epistemic point is sort of faced by everyone, so that sort of common ground that yeah, no one can know the microstate, and no one like saw the big thing happen. And so like the epistemic reasons for going for the path hypotheses are like these transcendental reasons, like if it wasn't true, we would all be bolts and brains and stuff. And I think those sort of transcendental reasons are available to everyone, whether you are presentist or eternalist or whatever. So I think it's an interesting thing, but I think strictly speaking, what needs to be explained is this microphysical thing. There might be a residual epistemic question, but I think we can give the same response.
So I might just point out that I feel like that's a bit in tension with like the Humean project. So it may well be that if you come in with these kind of fundamental causal notions, like you said, you're sympathetic to the powers view, as am I. And so I feel like then you get this nice kind of look, the base situation is what's now, and that's productive. Yeah. But I feel like the Humean rejects all that, right? Oh. And they, you know, so they may prefer to have the past hypothesis take this kind of metaphysical place, kind of via this weird, like transcendental argument, but just, yeah, keeping in mind a different methodology.
I think also we have to look at the package. So like the Humeanism has this big package, and the powers has this big package. And if you look at the Humean package, Markovianism is an inexplicable coincidence, but it's not in our view. We think that's the benefit of our package.
And if I may just add something on that, part of what we think is that we want to look at the fundamental physics because I think everything else supervenes is grounding in that. If it turns out that thermodynamics or whatever was literally something extra, then of course, a failure of Markovianism there would be evidence for eternalism, just that we think that is not true.
Yes, so I think the argument is a little bit quick in the following respect. You identify two forms of presentism and then move from that to, you know, presentism can do this explanatory work. And if, you know, the world turns out to be non-Markovian, then presentism is somehow falsified. It's a bit quick because there's lots of versions of presentism that just don't uphold the two things that you identified. And in fact, the two views that you identified are probably two of the least popular forms of presentism endorsed by presentists. Most presentists will think that there's causation between the past and the present, and very few presentists adopt the Markovian picture, partly because it's hard to square with indeterminism, actually. And so I'm a little bit, I think, you know, that the argument should be a little bit qualified unless, and this is the question, is there an argument for thinking that these are the two best forms of presentism that you should have?
Yeah.
Yeah. Well, right. So as you point out rightly, it's not presentism, presentism that explains Markovianism, but it's two versions, and something you don't like much is fair. I think it is still true, though that there is a second phenomenon, and it's got to be explained somehow. And these two versions explain it, and I don't think they take too little of a place in logical space, because we have causal powers, that is a pretty popular view of laws, and with any other conception of presentism. Then there's a nomic presentism that, yes, you might not like that very much. And we think that you can, if you like, you can think of it like this. There's three views on the table: eternalism, presentism that doesn't give us what we want, and presentism that does give us what we want. And we think, well, the striking fact of Markovianism is going to be explained. Maybe you can see it as an argument just for the specific version of presentism. And that still is a lot of reason to think it, just in terms of maybe likelihoods. I would not expect Markovianism at all, given eternalism. But given that I see it, I think, well, I gotta believe no matter what theory that gives us that, or at least I gotta increase my confidence by quite a fair bit.
Yeah, I agree with all that, but I'll say like the first view is intended to be a completely generic version of presentism for any presentism, except it's rather committed to a particular non-humanism that rejects primitive laws and specification relations and goes for nomic constraints or grounded power. So that's a particular non-Humean view that can be combined with any presentism view whatsoever. And we think if you do that, then because there are no past causal powers and there's another condition or something, then it follows. So we think, yeah, I'll just highlight that. I think the first thing is committed to a particular version of non-humanism and any version of presentism.
Thank you very much to our speakers, and